Hi everyone, so my problem 14 says planet Z is 10,000 kilometers in diameter. The free fall acceleration on planet Z is 8 meters per second squared. And it asks A, what is the mass of planet Z, and B, what is the free fall acceleration 10,000 kilometers above planet Z's north pole. So I always write out knowns and unknowns. So known, we know that the radius of planet Z is 5 times 10 to the 6 meters, so that's just half of the diameter, and then I converted it to meters. And then we also know that the free fall acceleration is 8 meters per second squared. And then, so we are asked to find the free fall acceleration 10,000 kilometers above planet Z's north pole. So H is going to be 10,000 kilometers, which is going to be 1 times 10 to the 7 meters. And then unknown, so we don't know what the mass of planet Z is, that's what we're asked to find, and we also don't know what the free fall acceleration 10,000 kilometers above the North Pole is. That's also what we're asked to find. Okay, so since we know that we need to find the mass of planet Z, if we go back to the textbook, we find that equation 13.11 says that the mass of the planet is going to be equal to the free fall acceleration times the radius of the planet squared divided by g. And we also know that this big G is the universal gravitational constant, which is going to be 6.67 times 10 to the negative 11 Newton meters squared divided by kilograms squared. And then to find the free fall acceleration, there is an equation that was derived from Newton's second law that says that the free fall acceleration is going to be the free fall acceleration near the surface divided by 1 plus h, which is whatever distance from the surface you want to find the free fall acceleration for, divided by the radius of the planet, and all that is squared. Okay, and then so to solve, so for A, I'm going to plug in the value of g, little g, which is 8 meters per second, and then times the radius of the planet, which is 5 times 10 to the 6 meters, divided by big G, which is 6.67 times 10 to the negative 11 Newton meters squared divided by kilograms squared. And then if we cancel out units and plug that into our calculator, we get that the value of the mass of a planet is going to be 3 times 10 to the 24 kilograms. And then for part B, same thing. I'm just going to plug in numbers into the equation for the free fall acceleration. So the free fall acceleration is equal to free fall acceleration at the surface 8 meters per second divided by 1 plus the distance from the surface, which is 1 times 10 to the 7 meters, divided by the radius, which is 5 times 10 to the 6 meters, and all that is going to be squared. And then if we plug that into the calculator and cancel out units, we get 0.89 meters per second squared. And that is the whole problem. Thank you.